Hey guys, I'm going to be working through an example that can be found in Greenberg, and hopefully this will give you a better idea of how to work with the p-set. So our equation is this. We have this as our center value, and we'll be finding the Taylor series and the radius of convergence, as well as a n plus 2. Just to keep in mind, x0 is usually not given to you, so you'll want to use the x that is given in your initial conditions. And another thing that your x0 has to satisfy is you have to check that whenever you divide across and standardize your equation, that x0 will not give you something that equals 0 in the denominator. So for example, if I standardize my equation, I'll get y prime minus 1 over x squared y equals 0, and x0 equals 2 is not going to give me a 0 in the denominator, so that's okay. Okay, so the first part of the problem is to find the Taylor series. I would want to first standardize my equation where p of x equals 0, q of x equals negative 1 over x squared. To find the radius of convergence, you would want to find the radius of convergence for the individual polynomials through the Taylor series expansion and find the minimum of those two values. So first off, we're going to work with q of x equals negative 1 over x squared. This is your standard Taylor series expansion form. Plug it in, so your f is going to be negative 1 over x squared. Evaluate it at the center, and you're also going to have x0 equals to 2. So for this next step, usually what I do is just tweak around with finding the first order differential, second order, and then trying to find a term that satisfies those equations. And remember to evaluate at x equals 2. This is how you get the 2 to the n plus 2 power denominator. So once you find this, you want to factor everything so that you only have this term and your x minus 2 to the n power term for the next step. So the next step is to find the r value. You take the limit as your coefficient. Plug in n plus 1 to this term, you get this. Plug in n to this term, you get this. Cancel everything, take the limit as n goes to infinity, and you get 2. So why we didn't evaluate for p of x, the radius of convergence, is that the radius of convergence for a constant polynomial is just infinity. So the minimum of the two radiuses is going to be infinity for p of x and 2 for q of x. So the minimum will be just 2. Okay, so for the next part of the problem, you'll want to find a n plus 2. The best way to approach this is to keep your original equation. So I want to, at first, work with the standardized form, but you'll find out that if the denominator here is like x minus 1 or x squared minus 2x plus 4 or something really crazy, it's going to get really complicated. So start out with the original equation that you had. You want to work everything in terms of x minus your center. So in this case, I'm substituting x tilde to be equal to x minus 2 into the equation. This is your standardized form f, so you plug it in. X tilde plus 2 squared, which is just x squared. This is still x squared. I just want to put everything in terms of x minus 2. If you take the second order differential, you'll get something like an times n minus 1 times x minus 2, and then the second order differential is going to give you n minus 2 in the exponent. Just plug in y. And then I'm expanding out this term here and keep your others the same. So this next step, what you want to do is take the summation from 0 to infinity, take out the x in, and then have this whole big term equal to 0 because this is what you have in the beginning, right? And then you want to solve for a n plus 2. So how you get from this step to this step is you multiply these x terms in. So for this part, I'm going to get x squared times x to the n minus 2, which will just give me xn here. And if you look at the coefficients, I want to start from n from 0 to infinity. But if you realize that when n equals 0, this term just equals 0. When n equals 1, this term is equal to 0. So you could just directly plug in n times n minus 1, which is what I did here. Same thing for 4x times this. You'll get something x to the n minus 1, something from 2 to infinity. Use the substitution variable m equals n minus 1, and you'll get something along the lines of this. So do it for all the terms. Plug it all in. Don't worry about this term. Equate this whole thing to 0 and solve for n plus 2, and you get this. So hopefully that gives you a better idea of how to work with the p-set, and thanks so much for watching.